In this question, the worker is pushing the box with a force of 80 newtons and the box moved 40 meters. So to calculate work done, the formula is F. So work done is F times force times distance. And take note that in order to use this formula, the force and the distance must be in the same direction. So the worker is applying a force of 80 newtons to the right. So 80 newtons, force is in newtons. The distance that the box moved is 40 meters. And I can substitute them into the formula because the direction is the same. So worker pushed in this direction and the box moved in this same direction. And the next part says, other than this force that the worker apply, what are the other three forces? So if you read the question, take note that the question says it is a rough surface. So we would expect friction. So in this case, the worker's force, we don't have to say it because they say other than the worker's force. So any mass on earth, there will definitely be a weight that's acting downwards. In fact, I think in this case, the weight should be closer to the middle, right? I think I should draw it closer to the middle of the object, right? Um, so the weight, when we draw, we will always draw it near to the center of the object. Okay, we'll start from the center of the object. So this is the weight that's pulling it down. Because they said it's a rough surface, and if the object is moving to the right, the friction must always be acting in opposite directions to the left. Again, take note that this arrow must always be drawn between the two surfaces because friction acts between two surfaces. So you must draw it in such a way that part of it is between the box and the floor. And not to forget that when you place an object on the surface will exert a contact force. And when you draw contact force, it is always from the surface towards the object, and this is the normal contact force. So this is actually 90 degrees. For weight, it's vertically downwards.